Hey folks, so in this video I want to talk about how we can use a list to represent our stack data. Now I've already gone through and done a simple implementation of a node. So what is that bias? That bias is a linked list. So you can see up top I have this diagram here, which looks a little bit like what I drew in that video. I have node after node after node with arrows between those nodes showing how they're connected. Now the arrows are only going in one direction, from left to right, I don't have any arrows going backwards, so that means that this is a singly linked list. So this basically is what we want to use to store our data. Now imagine for a second we have our stack. Our stack has some data inside of it. That implies that it's going to have some list inside of it, right? So perhaps like that second picture I've started to draw there. Now in a stack, I have to care basically about one side. I'm going to add or remove from the top of it. So let's go ahead and actually kind of label that. We're going to say there is maybe a variable called top, which keeps track of the top of this stack. So what is the last item that was added on there, right? What is the topmost thing, right? That's what we'll keep track of. This will be similar to the n variable when we talked about the array-based implementation. Note though in that n referred to basically an array index, right? A specific number. Here, our arrow there, right, our new top variable, isn't going to store a number. Rather, it's going to store a reference to the topmost node, right? So we don't have array indexes anymore. We have object references instead. Okay, now as we call push, as we call pop, this top variable will change, right? So if I do, for example, a pop, I will basically have in my picture might change and update to pull back, right? So all of a sudden the arrow is maybe looking at a different node, right? My top is looking as a different part of the stack, right? So as I do things, right, that arrow, right, that top variable, right, will move up and down, right? So just keep that in mind. Now, when there isn't anything on the stack, we'll just assume that top is null, right? So that'll be the way we indicate there's nothing in there, right? Because normally we want top to point out this element that's at the top of the stack. Well, if there's nothing there, what else are you going to do except point to null, right? So if there's nothing in there, we'll say that it points to null. All right, so this is our current plan. What we want to do is think about implementing push to add something to the top of this list or the front of this list, and then pop to remove something from the top of the list or the start of the list. So that'll be our plan. So if you think about it, right, just to trace a little bit more, right, this is how things are going to look over time, right? According to our scheme we just came up with. Initially, right, we'll create a stack, and our stack is empty because I haven't had a chance to add anything to it. So that top variable will be pointing at null. Nothing exists yet, right? So there's nothing there. Now if we do a push, then something happens. We have to, 1, create a node, and 2, update that top variable to point at that new node we've just constructed. And so you can kind of see that there in the middle, right? I have this new node which stores number 6, and my arrow is now pointing to it, right? So top is now non-null. It's pointing at the thing I've just put, right? Continue our trace a little bit. We do another push, right? We add now the number 2, and now we created a new node, and that new node should be connected to our existing node, and then our top updated, right? So a little bit more complicated because we need to basically link things together, right? We can't just move top up by itself. We need to make sure that as we move it up, right? Well, as I move it up, you can think to yourself, right? I don't want to forget about B, right? I don't want to forget about 6. I need to somehow remember it. And the way I remember it is by going to 2 and basically saying, oh, the thing that comes after you is that number 6, right? And then I have a linkage between the two that'll kind of be used to remember them over time, right? And I build a chain. As you can imagine, I'm adding. Every time I'm creating a new node, link it to the stuff that already exists, and then moving up top. I do that again and again and again, and I get a long chain at the end of the day. Okay, so things will kind of change over time. If we do a pop, we'll end up kind of pulling back, right? Our arrow again, right, would move from the topmost element right to the thing underneath it. All right, so that's our basic mechanic. In the next couple of videos, we'll start looking about how to actually implement the code for manipulating a stack like this.